So glad to see you back, everybody. It is lesson 7-4, and today's lesson target will allow you to say, I can recognize and use numerical patterns. Let's start by defining what a numerical pattern is. So all that really means is it's a sequence of numbers. You can see the definition right there. And the sequence of numbers shares some kind of relationship. Each number in the sequence is called a term. So in the pattern that you see right there, there is a 3, a 5, a 7, 9, and 11. There are 5 terms in that sequence right now in that pattern. And the first term is 3, the last term shown is 11. The first thing we want to do when we are looking at a numerical pattern is try to figure out what the pattern is. And this one's fairly simple to see. We can see that each term goes up by 2 from the last. So 3, and then we add 2 is 5, add 2 is 7, add 2 is 9, add 2 is 11. So we can very easily guess what the next term would be. We know the next term would be 13. But our goal is to be able to figure out what maybe instead of the 6th term would be, what would the 12th term be without having to go through and add 2, 2, 2, 2, 2 every time, which is why we're going to learn how to write numerical expressions, and you know what an expression is from our previous lessons, that actually show the relationship. So the expression is shown in the second row of this example. There are 2 different expressions being shown. So we have the term 3, and underneath it the expression to show 3 would just be 3. But then we see the next term, 5, can be shown by 3 plus 2, which underneath that we know is the same as saying 3 plus 1 times 2. And the reason it's 1 times 2 is because 2 has been added 1 time. So if we look there at that, we can see it's been added 1 time, which is why if you go to the next term, we have 3 plus 2 plus 2. And that can be shown with 3 plus 2 times 2 because 2 was added twice. And we can see that pattern continue to the 4th term, and we can see that pattern continue to the 5th term. On the 5th term, 11, we see there are 4 2's being added in the first expression, which is why there is 3 plus 4 times 2. Now, I hope you're also seeing another relationship, that 11 is the 5th term, but we're doing an expression that shows 3 plus 4 times 2. I want you to try to think for a moment why, if it's the 5th term, why it would be 3 plus 4 times 2 and not 3 plus 5 times 2. Pause your video for a second and take a moment. Okay, so when you thought about it, did you see that there were 4 2's added? Okay, that's the simple answer, but the other reason is that even though it's the 5th term, the first term is already represented here with the 3 plus. So I only have to show what's happening after that, which is why I'm adding 4 2's, or 4 times 2. So if I want to write an expression for the 6th term, I can say 3 plus 5 times 2, because I'm going to end up adding 5 2's onto the first term, which was 3. Doing that will give me the 6th term. Another way to write an expression for that would be take the first term of 3 and add on the 5 2's. That takes me to the 2nd term. Here's the 3rd term, the 4th term, the 5th term, and my 5th 2 would take me to the 6th term. So if I want to write that next term, I can simply say 3 plus 5 times 2. So that 6th term would be 13. And again, I'm sure you're probably thinking, well, yeah, Mrs. Brose, I can add 2 to 11. But let's take our example earlier of what if I wanted to go to, instead of the 6th term, maybe the 13th term or the 12th term or even the 10th term. So instead of having to add on from 3, if I wanted to go to the 10th term and add on 2 9 times, plus 2, and have to do all of that work. If I want to start from where I'm at and just go up to that 10th term, I could say 3 plus 9 times 2. Not 10 times 2, but 9 times 2, because remember, this is the first term, and I would add 9 to go to the 10th term. So 3 plus 9 times 2. 3 plus 9 times 2 would end up giving me 3 plus 18, which would be 21. So the 10th term in that pattern, or if it continued, would be 21. Are you hip to patterns yet? No? Okay, let's try another one. So here in this example, they're asking you to write a pattern that begins with 5 and then adds 5. So that part is fairly simple to do. I start with 5, and then I just add 5. So 5, 10, 15, 20, 25, and so on, and so on, and so on. Okay? It asks me to write the first 5 terms, which is what I've done. 1, 2, 3, 4, 5. I've written the first 5 terms, and they follow the pattern. It begins with 5, and each term goes up by 5. But now we need to write an expression. And specifically, they're asking us to write an expression for what will happen for the 6th term. So let's start by looking at maybe what an expression might have been to show the 3rd term and maybe the 4th term. So we can use that to make an expression for the 6th term. So the first term, the expression, would just be 5. The second term, the expression would have been 5 plus 5, or we'd think of 5 plus 1 times 5. The third term, we could think of 5 plus 5 plus 5, so 5 represents the first term. I add 5 for the second, add 5 for the third, or we can say it is 5 plus 2 times 5. Even though this is the first term, this is the second term, and this is the third term, instead of saying 5 plus 3 times 5, we're doing 5 plus 2 times 5, because remember, that first 5 represents the first term, and this is how I get to the next 2 terms after that. So the 4th term then, let's jump right to this expression, we would know would be 5 plus 3 times 5. Go ahead and try to write an expression for the 6th term. You can pause your video. Check your work above. How did you do? Were you able to write an expression that showed that the pattern would be 5 and the 6th term would add 5 more 5, so 5 times 5, and that the 6th term was 30? I bet you did. Let's move on to something new. The next thing we're going to do is look at 2 patterns. We're going to create 2 patterns, but then we're going to use what we've created to look for a relationship of how the numbers in the first pattern, how the terms in the first pattern relate to the terms in the second pattern. Go ahead and pause your video right now and do part A and part B, where you create the pattern that follows that direction. How did you do here? Were you able to come up with a pattern for the first part that was 2, 4, 6, 8, 10, and then 4, 8, 12, 16, 20 below? Of course you did. It was fairly simple to follow. But now let's follow the directions for parts C and D. In parts C and D, they want us to circle the corresponding pairs. That just means put together the number above with the number below. And they want you to look at how each term compares to the bottom term. So if we look at, these are our corresponding pairs. They want us to look at, first, how does the top compare to the bottom? Okay? The top is half of the bottom. 2 is half of 4. 4 is half of 8. So the top is half of the bottom. We're comparing the top to the bottom. Another way we could say that is the top is the bottom divided by 2. So let's check that out. The top is the bottom divided by 2. 4 divided by 2 is 2. 12 divided by 2 is 6. So we have that. Now we have to look at the relationship and flip it. How does the bottom compare to the top? Well, the bottom is double the top. The bottom is double the top. Another way we might say that is that the bottom is the top times 2, or multiplied by 2. Okay, don't be sheepish. It's time for you to try another one, but on your own. Here's an example of two numerical patterns. The first pattern begins with an 8 and then adds 8. The pattern below it begins with a 2 and then adds 2. Stop for a moment and think about how the terms on the top are related to the terms on the bottom and the other way around. How are the terms on the bottom related to the terms on the top when you look at the corresponding pairs? Pause for a moment and try to come up with a rule that shows how the top compares to the bottom and how the bottom compares to the top. Go ahead and pause now. All right, the sentences in pink are showing how the top relates to the bottom. The top terms are 4 times the bottom. So the top is the bottom times 4, or we might say the top is 4 times the bottom. If we flip it around and look the other way and think about how the bottom number is related to the top number, we can see that the bottom is a fourth of the top. Another way to say that is the bottom is the top divided by 4. Sometimes we might see these patterns and relationships in charts that give us information where we need to be able to compare how one thing is connected to another. So there are 3 examples here on the screen. In the first example, we're looking at how the number of bicycles is compared to the number of wheels we would find. So if we have 1 bicycle, we would find 2 wheels. The second example is looking at a relationship between concert tickets. And we're seeing that there are blanks in each. And this one is different than the first example because the first box in the cost for the tickets is blank. So we have to actually figure out the relationship based on what we have in the second and third terms. And then in the bottom example, we actually see some decimal values there. So the first thing we want to be able to do is try to determine what the pattern will be for the second value that we're given. Now, the bicycle examples are quite simple. If I have 1 bicycle, I'll have 2 wheels, and therefore if I have 2 bicycles, I'm going to have 4 wheels, and 3 bicycles is going to give me 6, 8, and 10. That's pretty obvious. The second example is a bit more difficult. I need to be able to try to figure out how I'm going to put, or what value I'm going to put in that first box for the second pattern, the first term. So the first thing I can look at is, well, I might ask myself, how is 70 related to 105? Well, I know that 105 subtract 70 would be 35. So it looks like there's a difference there of those 2 numbers of 35. Now I want to kind of test that to see if it makes sense. So if I look at a relationship between the top and bottom terms, if I use 35 to show the difference between the second and third terms, would 2 times 35 make 70? Yes, it would. Would 3 times 35 make 105? Yes, it would. So that is a good way for me to determine that 35 makes the most sense as the first term, and I can keep going with that pattern. 35 plus 35 is 70, plus 35 is 105, plus 35 would be 140. And then down on the bottom, we have a relationship that's shown with decimal values, but we're lucky enough that the terms are filled in completely for the first pattern, and the first 3 terms are filled in for the second pattern, and they give us a very obvious pattern to follow to fill in those last 2 boxes. So go ahead and pause the video now and try to fill in just what would go into the boxes of these charts to fill out the patterns and terms that we have left. Okay, hopefully you were able to fill out the rest of these tables or charts to show the correct remaining terms in each pattern that was there. Now, the next part of that is being able to look at the corresponding pairs on the table, so the top terms related to the bottom terms in each set. What I want you to do and what you're going to bring to class tomorrow is a relationship, a sentence that describes how the top relates to the bottom, and then the other way around, how do the bottom terms relate to the top? And you're going to try that based on what we did with the patterns before, where we weren't looking at tables, where we just had two numerical patterns to compare. So write down 2 sentences for each about how you might explain how the top relates to the bottom and how the bottom relates to the top. We'll see you tomorrow.